Hi everyone, my name is Andrew. I'm a graduate student at Springfield College in Strength and Conditioning, and I'm here to talk about my thesis. What am I curious about? Well, as a strength coach, I'm curious about hypertrophy, because hypertrophy is one important element for strength and power. The cross-sectional area of a muscle is directly related to the amount of force it can put out. And if you think back to elementary school PE class, who was the best kid in PE class? It was generally the biggest, fastest, strongest person. They were usually the best. And in sports, the same concepts typically hold true. And so the programming requirements for hypertrophy are pretty well known. We need to use short rest intervals. We need to use moderate intensity, somewhere between 60 to 80% of an individual's 1 rep max. You want to use high volume of training, so lots of sets, lots of reps. Sets to failure are also helpful, and also using big muscle groups. Those are also helpful. And so the reason short rest intervals have been suggested they're designed to reach a sort of physiological sweet spot, you can call it, where basically if you start a set of training too soon, the muscles haven't recovered and they're not ready to go. You'll only get a few reps and the muscle will basically crash and burn. But then again, if you wait too long in between your sets of training, you're not going to get an optimal release of growth hormone, testosterone, and a variety of anabolic hormones. And those are the ones that mediate hypertrophy. At the simplest level, hypertrophy is nothing more than an increase in protein synthesis over breakdown. So basically, you're building more protein than you're breaking down. And so the focus of my thesis is on these rest intervals, because short rest intervals, again, as I said, are designed to reach this physiological equilibrium. However, there's differences in an individual, in your fitness level, in your energy system recruitment, how tired you are. A lot of these things are going to affect how much time you need to recover, how much time you need to achieve this hypertrophic equilibrium. A helpful analogy would be, imagine a rule or a guideline came out that said, everybody has to wait 1 minute before drinking their coffee. So in every situation, you pour your coffee, you wait a minute, and it's always going to be the exact temperature you like. This guideline might work in a lot of situations, but what about environmental factors? What about if you're in the Arctic, and it's freezing cold outside? If you wait a minute, maybe your coffee's going to be frozen. What about personal factors? Maybe you're someone who just likes your coffee piping hot. And so you can see that a central guideline based on time is going to be helpful in a lot of situations, but it can't control for individual factors, personal factors and environmental factors. So I'm thinking my main thesis is I wonder if there's a way to individualize rest intervals to a specific physiological state. They do it in endurance training, in rowing and cycling. There's a way to do it. There hasn't been much research into strength training. So, my research question, do rest intervals determined by the time needed to reach a previous recovery state facilitate higher volumes of training during submaximal bench press repetitions to failure? So it's a bit of a mouthful, but I'll explain it as we go. So my studies, the heavy hitters. One heavy hitter is a study by Larson and Podger, and what they did is they took football players, 15 of them, and they made them do 4 sets of squats at 85% of their 1 rep max, and each set was to failure. And so they were looking at the performance decrement. What was the drop off between how many reps they could complete? And so they had 3 experimental designs. In one design, the athletes got 3 minutes between every set, standard, easy. In the second protocol, they had a 3-to-1 rest-work ratio. So however long it took them to complete a set, they got 3 times that to rest. And the last one, the most crucial one, is that the participants were told to rest until their heart rate came down to 60% of their age-predicted maximum heart rate. So that's a similar study design what I'm looking at. Unfortunately, they found no significant differences between the protocols in total volume. So that's contrary to what I'm looking for. However, the fact that they used squats and I'm using bench press, and the fact that they used a heavier intensity. They used 85% of a 1 rep max, which is a bit heavy for hypertrophy training. So these differences are enough to warrant a further investigation. Further heavy hitters were not just one study, but 10 of them. 10 studies using the bench press that all featured 1 minute rest between intervals. And they all showed that 1 minute of rest was not sufficient to maintain training intensity. So that's a real important key. And another heavy hitter, I suppose you could say, was a review article by Willerson. And it gave an overview of the variability between individuals in recovery and fatigue, all the things that can impact upon it, which was secondary to the thesis or the hypothesis that individual rest periods are going to give us higher volume outcomes. The theoretical foundation for this study, it's all about hypertrophic equilibrium, this idea that you want to start every set of hypertrophy training from this sort of metabolic sweet spot where the impaired muscle function from metabolite accumulation has passed, so the muscles work again. But you haven't gone too far in that you lose the good release of anabolic hormones. And so because of this recovery variability, I think that set guidelines aren't the best way to do it. I think individualizing them is better. So what do we know? We know that more volume of training correlates to a greater hypertrophic response. We know that rest intervals during hypertrophy training need to last long enough to allow for clearance of fatigue-inducing metabolites. We know that 60-second rest intervals are insufficient to maintain training volume. We know that significant variation exists in the time exercisers need to reach hypertrophic equilibrium. So our procedure, we used a randomized crossover design with 10 football players from Springfield College. And it was a pretty easy design. They ran on a treadmill at a 10% incline at 10 miles per hour until their heart rate reached 90% of their age-predicted maximum heart rate. They rested a minute. Then they did as many push-ups as they could in 30 seconds. And then after that, they started the bench press protocol, which was alternating sets at 60% of the 1 rep max, alternating sets between reps to failure, 8 reps, reps to failure, 8 reps. And the whole point of the study was to see how long they could continue this cycle for. Protocol A used 1 minute rest intervals throughout, real easy. Protocol B, they recorded the heart rate 55 seconds after the push-up warm-up, and all the subsequent sets started when the athlete came down to that heart rate. Who participated? Real easy, stats. I don't need to go into that too much detail. What instruments do we use? Again, pretty simple. Heart rate monitor, treadmill, stopwatch, standard barbell, and bench. All the things you find in a gym. So what did we find? We found a significant difference. We found that when you manage rest intervals by heart rate, you get more volume. We set our alpha level at 0.05. We used a paired samples t-test. The average sets completed in Protocol A was about 6. In Protocol B, it was almost 7.5. So we saw almost 1.5 extra sets when you calculate rest by time to heart rate. Here are other than that, no interesting stats. We had normal distribution, and the average difference between protocols is 22%. Similarities to previous research. We used hypertrophy type lows. We used 60-second rest intervals, tracked performance decrement. How is the study different? Well, we're the only study to calculate rest based on previous heart rate state. That's the big kicker. Limitations, we had no control over outside training. We assumed that the participants gave a full effort. We assumed that the 1 rep max data we got from their fitness testing was accurate. Practical application, if this is true, if heart rate mediated rest intervals give you more volume, we might get more hypertrophy. So practical applications is basically to use it. What's next? We need more research to see if a long-term protocol using heart rate mediated rest intervals gives us greater hypertrophic adaptation. And it'd be also nice to compare how participants' metabolic profile between the two protocols would change, whether or not concentrations of anabolic hormones and so on and so forth would change or be affected either positively or negatively. And that's an overview of my thesis. Thanks for listening. I'll answer any questions. Booyah.